A schema is a collection of database objects, including tables, views, indexes, and synonyms. You can arrange schema objects in the schema models designed for data warehousing in a variety of ways. Most data warehouses use a dimensional model. The model of your source data and the requirements of your users help you design the data warehouse schema. You can sometimes get the source model from your company's enterprise data model and reverse engineer the logical data model for the data warehouse from this. The physical implementation of the logical data warehouse model may require some changes to adapt it to your system parameters. And that is size of computer, the number of users who will access the data warehouse, the storage capacity that is needed to support those different users, as well as the amount of data that comes into your organization, and the type of network as well as the software that is run within the organization. The star schemas. The star schema is the simplest data warehouse schema. It is called a star schema because the diagram resembles a star, with points radiating from the center. The center of the star consists of one or more fact tables, and the points of the star schema are the dimension tables. The most natural way to model a data warehouse is as a star schema, where only one join establishes the relationship between the fact table and any one of the dimension tables that are available in the schema. A star schema optimizes performance by keeping queries simple and providing fast response time. All the information in each level is stored in one row. Note that Oracle recommends that you choose a star schema unless you have a clear reason not to do so. The next common type of schema is a snowflake schema. A snowflake schema is a more complex data warehouse model than a star schema, and is a type of advanced star schema. It is called a snowflake schema because the diagram of the schema resembles a snowflake. Look at the diagram provided here. You will notice that in the star schema, we only had relationships radiating from the middle table, which is the fact table in this case. But in this particular case, we have additional dimensional tables which have relationships with other dimension tables before we have a final relationship with a fact table. Snowflake schemas normalize dimensions to eliminate redundancy. That is, the dimension data has been grouped into multiple tables instead of one large table. For example, a product dimension table in a star schema might be normalized into products table, which in this case is what we're seeing here, and the product category table, which could be another table built for the purpose of associating the products with their categories. And then a product manufacturer, which would be an additional table again related to the products table, which holds information about who manufactured that product. Again, Oracle recommends that you choose a star schema over a snowflake schema unless you have a clear reason not to do so. There are other data warehousing schemas. Some schemas in data warehousing environments use third normal form rather than star schemas. For example, for each star schema or snowflake schema, it is possible to construct a fact constellation schema. This schema is more complex than star or snowflake architecture, which is because it contains multiple fact tables. This allows dimension tables to be shared amongst many fact tables. That solution is very flexible, however, it may be hard to manage and support. The main disadvantage of the fact constellation schema is a more complicated design because many variants of aggregation must be considered. In a fact constellation schema, different fact tables are explicitly assigned to the dimensions, which are for given relevant fact. Which are for given facts relevant.